Good afternoon and welcome to the final KTIF Tuberzone webinar. My name is Zach Riley. I work for SAC Consulting and I've been facilitating the Tuberzone project over the past year, working closely with our partners at Soil Essentials and Grampian growers. This webinar will last approximately 1 hour and I would like to encourage you to ask questions using the question panel at the side of your screen. We will try our best to answer all the questions asked throughout the presentations today, and we've scheduled some time following each talk. However, if we do not manage to respond, we will follow up questions with emails at a later date. Today, we have a packed schedule and we hope to provide you with an overview of the project and also some of the detail and results we have to date. I will start off the talk with a few slides about how the project has progressed over the last year. I will then hand over to Ian Riddle, Business Manager at SAC Consulting, who will share with you some of the objectives we set at the start of the project, along with the funding and background to this knowledge transfer venture. After Ian, Claire Dice and Nikki Smith from Grampian Growers will discuss why this project has been important to Grampian growers and what has been learned. Jim Wilson from Soil Essentials will then say a few words before we pass to the mastermind behind the model, Marcus Travers, who is going to talk us through the final results. This is the grayed out data and economic yield which has been achieved compared against the model predictions we made pre-harvest in 2019. Finally, we will hear some of the additional analysis that Stuart Whale and the potato team at SAC Consulting have been doing to find out if there's any additional agronomic information that can be gleaned from this project. We will of course stop for questions, so please keep sending them in using the box at the side of your screen and we will answer these as we progress. I thought I would just start with a slide recapping what the Tuberzone model is. It's a mathematical model designed to predict tuber growth throughout the season. The in-season predictions are based on a host of measurements which are taken in field, including satellite and UAV imagery, soil moisture and weather forecasting. Although Tuberzone can accurately predict potato yield and size distribution, the model cannot predict the number of tubers which have been set, so we carried out early season test digs in July of last year to count tuber numbers. The model uses this information and provides a 2-week forecast of potato growth. Here's an example prediction showing the date along the bottom of the axis and the fresh weight yield along the side. Each coloured section in the graph represents a different size fraction of potatoes. The size fraction is particularly important in the seed and salad market, as potatoes which are too large may increase the total yield, but will likely reduce the economic return as they are worth less money. The project to date has followed the growth of potato crops. We've had 3 grower meetings throughout the season. The first meeting was an introduction to the software and a demonstration of the predictions it can offer. The second meeting focused on the test dig information. At this point, it was clear how important the test dig location was. The identification of test dig location using GPS coordinates based on the satellite imagery was proven to be highly valuable. This was for 2 main reasons. Firstly, to ensure that the dig was representative of the crop, and secondly, that the dig numbers were reduced to ease grower workload. Our third meeting was in store at Grampian Growers, where Soil Essentials were able to share comparisons between the box count data, that's the number of boxes harvested in each field, against what the model predicted. Although this wasn't the final results that we will share later today, it was a great insight into the performance of the model. Throughout all the meetings, it's been great open discussions within the group about how this model can be improved to the benefit of all. Alongside the grower meetings, we've also had regular training sessions to help the group use the new software, and as the season progressed, we provided weekly reports for growers with information about predicted crop development and advised burn down decisions. These predictions were used to provide economic yields, so the group could see in monetary terms what it costs to leave the crop an extra week to mature or to burn it down straight away. So to bring my section to an end, I thought I would just include the main findings from my point of view. Firstly, I think that the accurate targeting of the test digs using GPS is highly valuable and is something which I think all growers could adopt. I think that the accuracy of the predictions is incredible both at a yield and a size fraction level. and with further development, this can make a real impact on the industry. And finally, I think that the early marketing of crops based on these predictions from the model could help to increase returns for both Grampian growers and everyone who grows Jemson. So at this point, I'll hand over to Ian, who's going to present on how this project came about, and we'll pause for some questions after Ian's section.
Thank you, Zach. My name is Ian Riddle, and I have been the project manager of the Tuberzone KTIF. I'm going to give you some information on the background and the objectives of the project. In background, it's a collaboration between three organisations, SEC Consulting, Soil Essentials and Grampian Growers. How did it come about? I remember it started when I had a call with Jim Wilson to ask if he had any good ideas for an arable KTIF, because we hadn't had many at that stage. Jim then suggested Tuberzone because it was something they developed and tested on farm. And we then approached Grampian Growers and Mark Clark, the CEO, who was very enthusiastic about getting the growers involved in this. So it's been a good collaboration between the three parties. We have the technology or the software developed by Soil Essentials and the backup and training. We have the established grower group through Grampian Growers, who've been able to provide organisation and a lot of the communications with the growers. And we've had organisation, facilitation and technical input from ourselves at SEC Consulting. And the technical specialist input has been very important. It's given us a chance to verify what we are achieving in practical terms from the data that we've been gathering. So we put the three together and we've been able to make, I think, significant on the ground improvements. Funding has come from the Knowledge Transfer Innovation Fund. This is a Scottish Government fund, part of the SRDP that's been running for the last 5 years. It funds what are called operational groups of farmers or others in the supply chain to look at a particular problem or a new solution in an innovative way. And the aim is that the group benefit from it and the wider farming community or the wider supply chain can also benefit from the findings. It's all part of a European network that's managed by EIP Agri. And if you want to find out more about other European projects, have a look at the EIP Agri website. The operational group has two parts. There's the wider group with all of the 29 Jemson growers involved and the other parties. And there's been a management group of 10 with the key players who have overseen the project over the year that it has run. If you look at the left-hand picture from the store, you can see that we've got quite a few youthful faces. It's been a good facet of this exercise, and some, like myself, not so youthful, but very enthusiastic, which is the main point. On the right, you can see our first meeting, which was held in a field at Fettercairn on a very warm summer's day, almost exactly a year ago. Our objectives, two main objectives. One is to encourage the successful uptake of Tuberzone potato technology by growers, and these were specifically the Jemson growers working with Grampian growers. We're aware that farmers have different attitudes towards technology. You've got techie people who will be very keen to adopt it. You've got other people who'll need quite a lot of support. Our challenge was to get the growers to adopt this en masse with quite a lot of support, with the aim of assisting the growers in their burning down decisions, which ultimately leads to better sale values and better farm profitability. Our second objective was to provide a high level of support to help the growers adapt to this technology. And we're keen to learn what's worked and what we could have done better. And after this webinar, we'll be releasing a questionnaire to the growers who were involved in the project. And we would very much welcome your comments and feedback, which will help inform both this project and other agricultural technology projects. I'm just going to finish with a couple of pictures. For me, the meeting we had last July, this was held a couple of weeks maybe before the burning down stage in a potato store, was a turning point. Prior to this meeting, Soil Essentials and Grampian growers had sent each grower individual records for each of the fields they had through the project. And you can achieve quite a lot by sending the individual grower their information. But to me, it really makes an impact when you do this as a group. And when we handed out the information, and you see a chap on the left looking it up on his phone, there was a huge amount of engagement and discussion. and growers asking each other, why is yours ahead of mine? What have you done differently? And that's the real value, I think, of working in an operational group. So back to you again, Zach.
Thank you very much, Ian. We've got a quick question from the audience here. Is funding still available for similar projects?
The current run of KTIF is, I believe, coming to an end. It runs up until the 31st of March next year. And I believe there may not be many opportunities for new projects, but the government are looking to see if they can get similar schemes set up in the next round of SRDP. So nothing immediate.
Okay, thank you very much. We're now going to pass over to Claire and Nikki from Grampian Growers.
Thank you, Zach. Good afternoon, all. For those that don't know me, my name is Claire Dice, and I work in the procurement and marketing side of Grampian Growers. My role in the project has been primarily in field and liaising with our 31 Jameson growers regarding the project. During Emergence and throughout the growing season, I was out with the drone in selected fields once a week to produce a UAV map to contribute to the satellite data and the model produced by Soil Essentials. I was also involved in the test digging process, along with assistance from SAC and Soil Essential across 66 crops of Jameson.
Afternoon, I'm Nikki Smith and I'm the Field Production Manager at Grampian Growers. Throughout the project, I was involved in test digging the crops and I collated all the grade out figures to be compared against the model.
So what do Grampian Growers want to achieve from Tuberzone? I've just noted down a few points. So first of all, increasing the maximum saleable yield of Jameson. This is in the 25 by 55 mil seed bracket, so ideally less oversized 55 ups. To increase the saleable value of Jameson and the returns to the growers. Refining our testing process and the accuracy. Having more specific burn-off dates for each crop. And just as a company, gaining a more in-depth understanding on the new technologies available to the industry. So what did we gain from Tuberzone? Well, targeted digs were a huge benefit to us. It allowed us to identify the best points in the field to dig using accurate GPS data. It reduced the number of test digs that were carried out on each crop, as well as having more increased accuracy. The targeted digs saved us a lot of time second guessing where best to dig, as the GPS points took into consideration all the variables in the field. Throughout the growing season, Soil Essentials had crop-specific reports produced from the model, which allowed Grampian and our growers to look at the current yield, size bracket percentage, as well as the value of that crop at a specific time. The reports also estimated these figures on a future weekly basis, which gave us an even bigger picture to help aid decisions. The reports also gave each crop an advised burn-off date based on the aforementioned yield, size and value. These were very informative dates to ourselves and the grower, as we used them as a guide to plan around spraying and pulverising. Having all this information available to us while the Jameson crops were still on the ground allowed Grampian growers to plan early on in the season. It gave us a guide of the total estimated tonnage from all crops, as well as an estimated percentage in the saleable bracket.
Overall conclusions and potential future use by Grampian growers. Grampian are always looking for new innovative products that will aid decision making and increase profitability to our growers, whether that be in potatoes, bulbs or flowers. Tuberzone has done that by giving us a greater understanding of cloud-based satellite technology systems. By having specific and targeted digs, resources and time spent doing test digs have been greatly reduced. However, some growers would be reluctant to change to a technology-based tool rather than using their own experience. Growers need to have trust in new technologies and adapt to new systems if they want to achieve the benefits. It is hard to tell if Tuberzone increased saleable tonnage, as a majority of growers burned off when they felt the time was right rather than using the estimated dates. However, as confidence grows in the accuracy of the model, more growers would burn down on the Tuberzone dates provided. Grampian growers have introduced their producers to Tuberzone technology and feel it would now be more beneficial to the individual growers to carry the technology forward themselves, with the support of Soil Essentials. We would like to take this opportunity to thank Soil Essentials, SAC, SRUC and our growers for working with us on this project.
Okay, thank you, Zach.
Thank you very much. A couple of questions. Claire, I think this one's probably for you. It's looking ahead, will Grampian growers change how they carry out testings?
Yeah, we have discussed this after using the Tuberzone model, and obviously having the targeted digs was a huge benefit for us. And we were hoping, you know, to see if Soil Essentials, if that's a service, a sole service, they would maybe offer to ourselves. As Grampian, we carry out all the testings on the Jemson crops on behalf of our growers. So yeah, we would hope that Soil Essentials would maybe take that into consideration if it's a service, a sole service they would like to offer to us in the future.
Excellent. And there's another question here for Nikki. What would Grampian growers say the biggest benefit of Tuberzone was, but to the growers?
I think the biggest benefit to the growers was the weekly reports they received throughout burn down from Soil Essentials. The growers could see not only the yield and size distribution the crop was sitting at for that week, but they could also see what the model predicted if the crop was left to grow on another week.
Fantastic. And I think we've got time for just one more question, and a few people have asked this. Is how many test digs are carried out per field?
I'll answer this one if you want. So we did about, if you take an average field of Jemson, if it was about a 4 hectare block, on average it would be about 3 test digs per field. But obviously they're more targeted, so less times you have to go and visit the crop. So yeah, roughly about 3, but it all depends on the size of area of the Jemson grown, but certainly the way that we have carried out testings in the past, we've found this new model, the Tuberzone way, has been much more efficient.
Excellent, thank you very much. We're now going to move on to Jim and Marcus from Soil Essentials.
Hello, thanks, Zach. Yeah, my name's Jim Wilson. I'm Managing Director of Soil Essentials, but I'm actually a lifelong potato grower, seed potato grower. And I want to give you a little bit of background into why we came up with the Tuberzone concept and what problems it solved. The problem is that as seed crops grow rapidly, they are changing value quite quickly, really. Effectively, in the Jemson crops that we monitored this last growing season, they were changing value at about £180 per crop per day, and we found that in my experience, it was absolutely key to gaining peak value for a potato crop was to burn down exactly the right date. A few days too early, you were losing a few £100s a hectare. A few days too late, you were losing a few £100s per hectare. So we came up with the concept of the Tuberzone model to try and give growers a little bit more of an insight into when exactly they should be burning down and what would happen if you left it another week, because another week you get more tons, but the tons are probably worth a little bit less. The other problem was that I always had an issue trying to burn down crops at the right time when I was very busy doing other things on the farm, usually combining crops. So you had to go and take test digs as whenever you had time, and perhaps this would slip a little bit if you didn't do it properly. The other issue was that, as Nikki and Claire have identified, I always thought that digs were notoriously inaccurate, especially if you were short of time. And often the results you got from the dig didn't necessarily tie up with the final grade out. So we came up with the idea of Tuberzone, which is, as Zach has already said, a spatial crop model that accurately forecasts the potato yield and size distribution at your current date, but also 2 weeks in advance, so you can actually decide, based on the value of each size fraction of the crop, what is the most economic time to burn down that particular crop. And the nice thing about it is that as each crop is different, you can get a report produced on a single crop or across all your crops, or indeed all across the entire production, for example, of Grampian growers. And we focused Tuberzone on mainly seed and salad crops because those are the ones where size distribution is absolutely key to gaining maximum value of the crop. But of course, there's people in other countries using the Tuberzone model for both table potatoes, starch, and processing potatoes because they have similar problems but slightly different. And Tuberzone has now been validated across many different countries with many different varieties. Interestingly, it's all exactly the same model. We don't find that we have to adapt the model at all for different growing conditions and different varieties too much and different locations. It's all pretty much the same model, which is a testament to the model that's been built. Thanks, and just roll on. And then if we go on to the next slide, I mean, what is the problem? As I've already said, every single crop is individual. We've got different yields because they're growing in different agronomic conditions, and those different soil conditions, different weather conditions, both within and between the fields, lead forward to producing different total yields in terms of size distribution. But of course, each size has a different value, and therefore the crop value changes across the field, both within the field and across crops as well. And it's influenced very heavily by growing seasons and between years. So it's hard to predict. It's hard to compare what you did last year and the year before with what you're actually getting this year, because every year the weather's different, the crop's different, the fields are different. And the other problem is, as we've already said, is that crop digs, when you're doing crop digs, the size and value can change so rapidly across the field. So you need to do really quite a lot of crop digs and to get a representative sample if you're using a random method. And of course that takes time when you're busy, when you should be doing something else, and also it does no guarantee you're actually getting a good result. So one of the other benefits of Tuberzone was that we can actually pinpoint where the best place to dig was. And as I said before, the issue is that crop value could go down as well as up. If you've got a specific market fraction that you're trying to produce for that seed or salad or even bakers, I suppose, if you don't hit that, you're heavily penalised in the market. And that means that the crop value can go down as well as up. And it also means that a percentage of the crop, an increased percentage of the crop, becomes block, becomes waste. And that means that that's just a complete waste of all the inputs, the fuel, the fertilizer, time and effort for nothing. And all that happens to that fraction of the crop is that often it's sold at low value or it goes down a cow's neck. And if we go to the next slide, so the benefits are, as Nikki has I've already said, that we are targeting in-field digs using satellite imagery to make sure that we're taking those digs in an area where you can take the minimum number at the minimum time and actually get a pretty good representative dig for the crop. So we're reducing total crop digs, so it takes less time to do it. But for me, going back to the original problem of knowing when to burn down the crop at peak value, what we saw with all the Jemson crops was that, as I said, they were growing in 2019 at around about 5 tonnes per hectare per week. So every day you leave them to go on adds about another 180 quid per hectare to the bottom line. So on a 100 hectare potato enterprise, that's 18,000, which is a scary figure. And you think that your tatty crops are growing at 18,000, adding 18,000 pounds per day value over a 100 hectare potato enterprise. It's a sobering number, and if you can gain an extra few days, then to get up to the peak value, then that puts a lot of the bottom line. So another benefit is, of course, that if you know the value, how much growth is left in the potato crop, you can make then a choice of which crops to burn down at which times, which makes your harvest scheduling more accurate. So those are basically the Tuberzone, the benefits we see in Tuberzone. We are doing a lot of crops this year all over the world. If you would like to try one, I'm sure that we can help you with that. Thanks, Marcus. So I'm going to pass on to Marcus now, and he's going to take you through the results of the KTIF.
Thank you, Jim, and good afternoon, everybody. I'm Marcus Travers. I'm the lead modeler and data scientist at Soil Essentials, and my job is to look after Tuberzone and make sure it does what it's supposed to do. So we had 76 Gemson crops planted between April and May last year as part of the KTIF. And you can see from this map, there's quite a range in the geography of Scotland used for those crops. So it covers about 300 square miles of arable production, and there's about 100 miles between the most distant crops. And there's actually a change in elevation of about 400 meters. There's one of the crops was right up in one of the base of one of the glens, and so it was a fair altitude. Now we're going to look at some data comparisons. So obviously it's a good idea to know what we're comparing, because not all data is the same. So the model data is basically the biological yield for the whole field. So what we think the potato plants are actually producing in terms of potatoes in the field. Now they're traditionally compared to dig data, which are a subsample of that biological yield. So they're not actually a representation of the whole field. They're a subsample that we've then got to interpret into a whole yield figure. And that's where some of the discrepancies between dig data and actual yield comes about. Now, the first indication we get of an actual yield off the field is the box yield. So what actually goes into the boxes. And the box yield is essentially the biological yield minus the fact that the boxes are probably not properly filled, some leavings in the field, plus any stones and dirt. Now, the other thing is, of course, that the box yield is an estimated weight. So it's the number of boxes multiplied usually by about a ton, divided by the cropped area. Now, then the closest thing we get to an actual measurement of yield is the grade out yield. And that is, again, a measured weight graded divided by the cropped area. But it's a biological yield minus, again, any leavings in the fields, but also minus the weight loss in storage. And of course, that depends on the kind of storage and the amount of time the potatoes are in storage before they're graded out. So the first graph we're going to look at is a comparison of the box yield. So that's from the number of boxes multiplied by a ton divided by the land area compared to the model yield in tons per hectares. Now, it's important to know what limits accuracy. So there's some measurements of accuracy on there. The blue line is a one-to-one relationship. So if the model exactly predicts the yield in the boxes, then it would be on that blue line. That's notionally 100% accuracy. And then we have some lines showing where 90% accuracy and 85% accuracy would be. And you can see that most of the dots, the blue dots, fall within the 85% accuracy or pretty close, but there are a few outliers. So what I'm going to do now is try and get a little tool up that will allow me to point some of these out. So we have one down here marked in red where actually only part of the crop was lifted. So obviously the box yield has a bit of an error in it because not all the crop was actually put into the boxes. That's because it got very wet at the end of last year, and so the farmer just couldn't get the crop out the ground. These other red dots are actually where there's problems with the amount of area that was actually registered. So what happens is that often people measure the area that they've cropped on a map or something like that. But the problem is that if you measure it on a map, people don't often take into account changes in gradient. So it actually means that the area is slightly bigger than they've measured on the map. And there's all sorts of those things. Now, on a big area, that wouldn't matter. But on a small area, a small amount of difference can be quite a big error in that area measurement. There's also another crop here where there's a discrepancy between the number of boxes that were lifted off the field and the number and the amount of boxes that were actually supposed to come off the field. So it's possible that the number of boxes actually what happened was some of the boxes were actually included with another crop. We also found that all our data, because it's measured with created through satellite data, isn't appropriate for very small crop areas. So what we can do is we can use drone data for those, but we didn't actually do that within this use of the model, because we wanted to see what the limit was to the model. So what we found is that crops that are less than about half a hectare, or are a very thin strip with maybe only 4 or 5 beds in the strip, we can't get the satellite data accurate enough to actually run the model on those. There we go. Apologies. Apparently, if you have the marker pen on, you can't change the slide. So there we go. So this is actually the grayed out yield against the modeled yield. And what we're finding here is that each of the points here is a pair of points with a line. And what that shows is that the lower point that's in blue is the actual grayed out yield. So the amount of crop that was actually weighed at the factory. So these ones here, these blue ones here. And then the red ones above are a 10% addition to that value to account for leavings in the field. But what we haven't done is added in the possible losses due to storage, because we don't know how long these crops were stored or under what conditions at the moment, and that's something that we will try and find out perhaps from growers going forward. Now, what should be the case is that because there are natural losses, the blue points should always be below this blue 100% line, and in most cases they are. There are some that are very close or on that line. The reason being that these figures here will have some moisture loss and some dry matter loss due to storage. We've got a couple of figures here that actually come from the same field. They're 2 crops from the same field. And you can see they've gone either side of the line. And what's probably happened here is that when the crops gone into when they've gone into be graded, they've actually been graded together. And the only way we could estimate what the grayed out yield was by splitting it by the number of boxes. So if we weren't quite got the right number of boxes, or the boxes in one part were only partly filled, then what's happened is that we haven't quite split the data up appropriately. So now I'm going to look at the grayed out data against the dig data. Now, as I said with the model data before, these grayed out figures should really, all these points should be below the blue line, but actually you can see with the dig data, there's a much more of a scatter above the blue line and below the blue line. Now, I've put some numbers on here, and what they are the number of digs that were taken in each crop. And you can see that the majority of the ones where 2 digs were taken per crop are actually within the 85% accuracy lines, showing that obviously the more digs you do, the more accurate it gets. Now, the problem is that with a lot of crops, you can have as much as 20% variation above and below the average yield within a field. That's fairly normal. And also, if you take into account the fact that any dig will have about 20% error in it anyway, in terms of the natural variability of the potatoes, that means that a dig in a field that's not properly targeted can be as much as 40% out. That means you've only got 60% accuracy with the dig, and that's being borne out more or less with the scatter of the data that we're seeing here. So what are the considerations we need to get an accurate yield measurement? With the model, area measurements are quite critical because we're doing all this calculation based around area. Any error in that area measurement will create error in the outcomes. So having good ways and accurate ways of measuring areas is quite important. And luckily, things like the satellite data platforms, geographical platforms that are available, like Core, allow us to make much more accurate area measurements of crops. And we can actually, with the satellite data, we actually see the boundaries of the crops, particularly if there's endrigs that denoting the boundaries of crops. We've got to be aware of how small a small crop is in terms of limitations as to accuracy and use of the model. And so we've got a good idea. Now, the good news is that we can actually get around that by using drone flights instead. And a lot of the small cropped areas we look at now, we advise that people have to use drone flights, and we can use drone data, and that's just ordinary RGB. That's the visual cameras. We don't need any sort of special spectroscopy. They're just an ordinary run-of-the-mill drone, and we can look at small cropping areas and trials and things like that. The other problem is that we need to understand when grayed out data is being combined, so we give a combined result as well. So we combine our data together to give a result for a combined grayed out. Now, with digs, the same sort of problems exist. The area measurements are still important when you're making that scaling up of a dig to an overall yield. Single digs in large fields are probably not a good idea unless you can measure the variation in that field, like with a targeted dig approach. And effectively, if your digs are more or less random, then you are going to be looking at quite substantial errors coming out of those digs. So just moving on to the size distribution, what I'm going to concentrate on is the 35 to 55 size band. So this data here, when we look at the accuracy of the model in a moment, the reason being that's where most of the potatoes should be. What we don't want is potatoes falling into this 55% band. So one of the things we look at in the model is that this modeled figure should always be slightly more than the grayed out figure here, because that means that we're ahead of the game, and that when we make our representations, we're making sure we maximize the return to the farmer and that there's no escapes into this this wasted fraction on this side here. And so what I'm going to now look at is how much accuracy, how much error there is in just this fraction here, because the closer we get to getting this right, then the closer we get to a proper economic yield for all the farmers. And here we go. So what we're looking at here is the number of counts. So this is the number of crops and the accuracy at the bottom. So what we can see here is that for about 26, 27 crops, we got the accuracy to greater than 95% for that size fraction I was just talking about. And then we got another 15 crops at between 90 and 95% accuracy, and then it starts to diminish. There are some where the accuracy is very low. Now, what we found is that there are a number of reasons for that can be, first of all, avoided in the future, but also taken into account. So the first is that when we're looking at the grayed out data, we're actually looking at each of the size fractions as a percentage of overall weight, because we have to be able to compare like with like. What that means, though, is that if you've got a large amount of brock in that, you get bias in the data. So some of the ones in this area here that are a little less accurate are the ones where there was a substantial amount of brock in the grayed out data. Some of the ones in this area here and here are down to the fact that grayed out figures are produced from multiple crops graded out at the same time. So what happens is that those that are very large crops within that graded out fraction will tend to be towards this area, but the ones that are basically diluted, the smaller crops diluted by the bigger crops, will tend to drift towards this area, because what's happening is that the model prediction is looking at those smaller crops as individuals, but actually now they've been diluted by a much bigger crop that has a completely different size distribution. And then there's also a few crops down here where, when we got the crop information back initially, we were informed that they were 2 row in a bed crops, but actually there were 3 row in a bed crops. So the plant population was wrong in the model. And so what it highlights is the need to go back and double check with growers that the grower information is correct. So in terms, again, considerations for the model, Brock's not size, so Brock becomes an unknown in any consideration of size distribution. Short of people actually grading Brock as well, which is probably not a sensible thing to start doing. There's not much we can do about that, except perhaps putting some estimates of where that Brock came from. Combining grade out data is just something we need to be aware of, and then we can correct the model predictions according to that. And also we need to make sure that inaccurate crop information is picked up on as early as possible. And now we've got a set of validation processes whereby data is checked and cross-checked by various means to make sure that the data is correct. With digs, you've got basically the same sorts of problems. And again, you've still got the problems of single digs and essentially random digs. So what have we found out? What have we established as benefits of Tuberzone? Well, for the growers, targeted dig points and less digs are obvious benefits, but also knowing having a better understanding of the burn down date and when to actually stop the crop growing will potentially lead to a better value crop with less waste. On the corporate side of things, again, as Grampian growers have already said, targeted digs and targeted dig points is a good idea. We're also introducing this idea of targeted fields, so that perhaps not all fields need to be dug, but if we can find out what the similarities are between fields, then perhaps the initial digs, the early digs, don't need to be done in absolutely every field, but in fields that are representative of other fields. But all this is leading to less digs, which means more time to do other things. Having that crop size as well and size in terms of yield and distribution well in advance of harvest can really help with planning, both through through grading out, but also in forward sales as well. And again, less waste is a positive benefit from the whole process. So what have we learned from Soil Essentials as a company? What have we implemented from the KTIF? Well, one of the things we've done is set up a system whereby we can automate our targeted dig process. So these are 2 maps that have been created last week for 2 very early crops that were under fleece. And what we can see here is on the left here, we can see a crop that has quite a lot of variation in it already, such that we've been able to zone it into 2 zones, 1 and 2. And what we actually found was when the digs were taken at points 1 and 2, there was a 30% difference in the number of viable potatoes under that crop, which is quite a big difference between the 2 zones. That would lead to quite a different size distribution at harvest if you didn't know about it or weren't aware of it. In comparison though, this field that was not too far away from the first one only needed to be zoned into 1 zone. The red areas here are areas where the yield is a little bit or above or below the average, and so if you took the digs in those red areas, you would bias the results. So by sticking to the white parts, what you're doing is getting a much more representative dig of the field as a whole. So I'd like to thank you all for your attention, and I'd be happy to take any questions.
Thanks, Marcus and Jim. I've got a few questions here. The first one is, how do you get from 85 to 90% accuracy?
The straightforward answer to that is as carefully as possible. What we're very keen to do is not to compromise reliability for a pursuit of accuracy. We widely consulted with the industry, and were told by the industry largely that 85% accuracy is good enough, that they can work with 85% accuracy. So although 90% is a desired accuracy, we shouldn't pursue that and at the detriment of achieving that 85% accuracy, perhaps 99.9% of the time. So what we want to do is carefully make small adjustments to the model based on proper knowledge and intelligence and research and information that constantly improves the model, but also make sure that that reliability is never compromised.
Okay, thank you. And I've got another question here, Marcus. Can growers enter their own testing information?
Yes, they can. What we would do is we would liaise with the grower to make sure that the testings are carried out in a way that's comparable to the information we need. But we have a very flexible system. So as long as it meets some very basic criteria on things like recording the length and recording some sort of size fraction, then we're quite flexible in that. So yes, is the tentative answer to that.
Okay, super. Thank you very much. We're now going to hand over to Stuart Whale, who's going to give us some extra information that we've gleaned from the Tuberzone data set. Over to you, Stuart.
Thank you, Zach, and good afternoon, everyone. We, SAC Consulting Potato Team, have been delighted to be involved in this project. It's been a benefit not just to us, but to I think being helping both Grampian growers out and Soil Essentials to evaluate their product. Although I'm speaking, I'd like to say that this is on behalf of myself and Kieran Maloney. Kieran, the new lad on the block, has been instrumental, particularly in helping in the field and doing the analysis of the data set. So the objective of Tuberzone, as you've heard, is to predict progression of yield as accurately as possible from non-invasive in-field data, except for the testings, which has already been explained. And in order to validate Tuberzone, there's been a very large data set accumulated. And I'm hoping to change the screen here. I can move on, which I'm struggling to do. Wrong way. Got to the wrong end of the presentation. There we go. So these are some of the factors that have been measured. The ones in red are the ones we've looked at. And as the same as Marcus, we've evaluated the factors against the testings, the box yields, and the grayed out 35-55 millimeter fraction. So you'll see those in a minute. I'm just going to select some of the factors in turn, and I've just made single comparisons of the factor against the yields, the testings, the box yields, and the grayed out fractions. But of course, potatoes are complicated, and we will be looking at multiple factor analysis. I'll come back to that later. First of all, just planting depth. This was measured during the testings, and it's quite a range of depths. I think the shallowest planting depths, the 10 to 11 centimeter ones, were probably mini tuber pre-basic crops. You'll see the majority of the growers planted at 14 to 15 centimeters, which is about 6 inches, and that's sort of fairly typical for seed crops, but there are some in the middle. And so one of the questions we asked was, did it have any effect on yield? So you're going to see sets of graphs like this through the presentation. On the left-hand side, the red bars, the red dots is the test digs. In the blue is the box yields, and in the green is the grayed out yields. Although there seems to be, there's an apparent decline in yield as you go deeper. In my view, there's no strong indication. There's quite a lot of variability, but there's no strong indication here that planting depth had any effect on yield. If you've been planting a ware crop much deeper, then I would have expected there to have been some impact. So I want to move on to planting date, and you'll see the scatter of dots around the lines are closer with this. In fact, the correlation is better, and there is, in general, both for all three plots, a decline in yield, a small decline in yield the later you plant. Now this correlates well with long-term trial experiments at Craveston in Aberdeenshire, which show that after you move into May, then the yield potential drops. So that's not surprising. It's not a major drop in yield, and of course you can't put all your Jemson crops in early. You had to take them as they come, along with all your other varieties. But to bear in mind that the later you plant, the lower the yield. And this is quite simply explained by the amount of light capture. If you take the season length from emergence to Haulm destruction, it goes the other way. The yields are increasing the longer the Haulm is green, the longer you leave the crop to grow. And obviously if you plant early, then you get a longer potential growing season. So these results show that for the maximum yield, and obviously this is only considering the yield in particularly for the green lines, only considering the yield for the grayed out data, which is what you're selling. So on average, the longer the period from emergence to Haulm destruction, the greater the yield. Marcus mentioned altitude. There was a range of altitudes from sea level up to, well, in the data set we have up to about 200 meters, 600 or so feet. And the good news is the altitude had no impact at all on the yield of Jemson. Now, this is the graph that caused me most concern. This is the graph of the seed rate, the plant population in thousands per hectare, against the estimated tuber count. That's the number of daughter tubers produced. You can see that the number of daughter tubers produced range from 600,000 to about 1.3 million. So quite a variable number of tubers. And the reason we adjust the seed rate depending on the size of tubers you plant is to try and create the same number of stems and therefore the same number of tubers in every hectare that we plant. But the results show a very poor correlation with seed rate. And in fact, the trend line, which is the orange dotted line, suggests that in fact it's better to put in a higher plant population to get more tubers, which is logical, but it's not what we try to do when we give seed rates. And I suppose the consequence of this graph is that other factors in the fields, individual fields, have affected the seed numbers of seed tubers formed. And we may need to think again a little bit more about the seed rate calculations or seed rate numbers we give you when we know the tuber count per 50 kilograms. So considerable variability. So if you plant the seed rate against yield, you can see a trend in all three sets of data, whether it's the testigs, the box counts, or the grayed out figures. There's a trend upwards of yield, the higher the seed rate population. And finally, we measured in each field what the main soil type was, and they tended to be either a sand, a sandy loam, or a loam. And quite surprisingly, perhaps, although the data for the sands are more limited, in each of the tests, in each of the ways of calculating yield, the sandy fields had higher yields on average than the sandy loam or loams. Now, 2019, towards the end of the season, was a much wetter growing year, and it's possible that the crops in the sandy soils were at an advantage, and it may not be the same next year. But it does, to me, it does show that soil texture is a factor to consider when you're growing Jemson. So to summarize, and I'm going to start with a point made by every other speaker almost, that one of the things that Tuberzone does is to identify the most representative locations for testing. That is a real advantage in my opinion. And the data, which we haven't finished analysing, does provide information on agronomy. The depth of planting varied across crops but had little impact on yield. In general, yield declined slightly with later planting, and we think the reason for that is that there is a longer growing season with the earlier planted crops. Results suggest other factors affect daughter tuber number than just the seed rate or the seed plant population alone, and that means we need to look at seed rates a little bit more detail. All right. Overall, increasing the seed tuber population resulted in increased yields, and there was a suggestion that Jemson may perform better in sandy soils. So one of the reasons for doing this is, as you saw from Marcus's graphs, is that the yields varied from around 40 tonnes a hectare to up to nearly 70 tonnes a hectare. And we hoped we could pinpoint some of the factors from the data set which explain that variability. But, and we will do this fairly soon, one factor which we haven't yet analysed is the soil capability or the land capability of the fields on the old Macaulay, now James Hutton maps, which are available. So further multi-factor analysis may improve the understanding of the results. Thank you.
Thank you, Stuart. I've got a question for you, if that's okay. Somebody's asked if you had one tip for salad growers, what would that be?
I assume you mean Jemson salad growers particularly. I think the tip would be I think the tip would be uniformity. Uniformity for seed rate, uniformity in spacing, so you get an even stem numbers, even across the field, and even emergence, and all these three, and so on for uniformity. And these things all mean attention to detail, because you don't have much room for error in a salad crop.
Okay, excellent, thank you. I think we've got time for a couple more questions, so I'll try and work through. We do have quite a few that have come in. I think to start off with, I'll ask Claire a question. Somebody's asked from a practical point of view, how do people in the field find the testing location?
So from a practical point of view, as in without using Tuberzone, I'm guessing. So I kind of think we would normally kind of analyse the field. If there's any first of all, any gradient in the field would usually do a kind of bottom, middle, and dig higher up in the field, just to get you know, just a bit of equal kind of soil types and soil gradients in that way. If it's a fairly flat field, usually just a kind of straight diagonal of the field. There's nothing really scientific about it in that sense of way. That's why we're kind of hoping to adopt these new GPS targeted digs. But yeah, for now, what we've done in the past is pretty much just been a kind of random, you know, either diagonal of the field, or yeah, as I said, with the gradient, just going to make a dig in each part of each different section.
And using Tuberzone, how do you find the GPS point in that field?
So using Tuberzone, so we got some handheld GPS devices from Soil Essentials. I do believe we've got another kind of system, handheld system for us to use as well. And you can also use them on your phone. It's fairly simple. They send the points over onto these devices or your phone, and then they place them on a map on your phone, and all you've really got to do is walk towards the point, and then that's where you're digging.
Okay, thank you. Jim, I think this one is for you. What varieties can Tuberzone forecast, and is there potential to use it on different crops?
Thanks, Zach. Yes, we've specifically calibrated many different varieties. You know, I think 60 or so at last count. However, you can't actually use it on any variety at all. We just need an extra couple of calibration digs for the first few times we try that variety. So you can also run Tuberzone on the same variety in multiple different countries. It's actually the same model that's running there. So really, varieties aren't so much of a limitation. We can cope with that with some specially targeted digs.
And is there potential to roll this out to other crops, other high-value crops?
Absolutely, yes. Already working on several other high-value root crops in particular, you can imagine. So other types of potato crops, we've already been working quite extensively with ware crops, with starch crops, a big project on the go with starch crops, and processing crops in Europe. Other types of, as I say, other types of root crops, you know, sugar beet and onions and carrots, that sort of thing. Same basic principles apply. So yes, currently looking at that.
Fantastic, thank you. Marcus, I've got quite a big question here, so I'll have to ask you to be brief. What does Tuberzone do that other potato crop models don't?
Okay, there's a basic. This is for the nerdy modelers out there. So Tuberzone's a semi-mechanistic model, and many of the other models that are out there are stochastic. So that's a nerdy answer. There are others that run around a sort of a time temperature basis as well, whereas Tuberzone uses a lot more varied environmental data, so weather data, soil moisture data, that kind of thing. I think that the main thing that's probably different is not so much the model itself, but the way the attention to detail we pay on the data inputs. So there's an old adage in modeling generally, it's called garbage in, garbage out. And what we do is we spend a lot of time not just cleaning the usual cleaning of data in terms of not using satellite data with bits of clouds on and stuff like that, but actually looking at the data in comparison with the other data we've got to make sure that that data that we're using is fit for purpose. And that removes a lot of error from what we do.
Okay, brilliant. I think that ties into the next question here, that somebody's asked, how did you know that the area of crops were wrong? You mentioned that in one of your slides.
Because we were given, yes, yeah, because we were given a list by Grampian growers of what the farmers said they'd planted, and I went out and measured them. by various means. Sometimes it was people actually physically measuring in the field, and sometimes it was just having a look at the satellite image on a GPS system and drawing around them to calculate the area, and then doing a comparison between the two. So it's not really spying because the data's open access, but it was just validation, and it's part of that attention to detail that I was talking about in terms of the data making sure that what people say is right.
Okay, thank you. Now I think we've got time for maybe just 2 more questions. So Jim, how is the satellite imagery used?
Yes, so we actually get satellite imagery from several different systems, all working in parallel, and they have got lots of different resolutions. So first of all, we choose the appropriate satellite system and appropriate resolution for the job we're trying to do. Secondly, where it's used in the model is to validate the assumptions and calculations we make. Just as Marcus says, we validate things. So one of the assumptions and calculations we make is the amount of canopy that is present in each particular area of each particular crop throughout the growing season. So we make the calculation and validate that from satellite imagery. So we can actually use the satellite imagery to check the percentage ground cover of the crop, and that percentage ground cover of the crop drives the amount of light that is intercepted by the crop, amount of sunlight, which, as Stuart said, directly drives yield. So effectively, we're using satellite imagery to calculate how much light is intercepted by the crop, which then leads on to the amount of light that goes into the tubers, which predicts yield.
Okay, thank you, Jim. And then a final question that we've got time for today is for Stuart. Stuart, are you suggesting not to variable plant? Is the question here?
Not sure what you mean by variable plant. Different.
I think that.
Oh, I see. You mean the seed rate? No, I understand.
Yeah.
No. I'm not suggesting that. I think we need to use the data we have on the seed rate, number of tubers per 50 kilograms. It's just that I didn't. The graphs that came out of the graph I showed you was very different from what I expected. No, we need to start off with the logic, and we need to explain a little bit more why the difference in daughter tuber numbers varies from field to field. But no, I wouldn't change the seed rate calculation just yet.
Okay, excellent. Thank you very much. And thank you to all our panelists today. That's all we've got time for just now. We'll try our best to answer all the questions by email if we haven't covered them already. But thank you very much for tuning in to our audience. And that's everything from us today.